While SOLIDWORKS simulation is well known for its ease of use and ability to handle complex geometry, you may not be aware of the breadth of design challenges that can be tackled. The capabilities provided in SOLIDWORKS Premium are just the tip of the iceberg when compared to the depth of functionality available in SOLIDWORKS Simulation Professional, Simulation Premium, SOLIDWORKS Flow Simulation, SOLIDWORKS Sustainability, and SOLIDWORKS Plastics. We're going to take a quick tour of the key problems in testing you can use SOLIDWORKS simulation tools for to save time and design better products. When developing manufacturing machinery or industrial equipment, there are typically many moving systems that interact. Ensuring that movement is correctly sequenced or that the desired range of movement can be achieved without problems is vital. SOLIDWORKS events-based motion makes it easy by allowing you to sequence the movement of motors and actuators based on other events, such as proximity sensors being triggered or actuators finishing a travel. By driving movement based on logic, the total operation time is calculated, allowing you to vary the sequencing to minimize cycle time. Reducing weight and improving performance are key goals in most design projects to reduce cost as well as differentiate your products. Optimization allows you to quickly size the design to meet performance needs without excessive amounts of material. SOLIDWORKS simulation allows you to vary geometry as well as simulation parameters and readily review different variations that still meet your design goals, while optimizing aspects such as weight, deflection, or factor of safety. You are even able to review the simulation results for any of the design iterations to see changes in the response of the structure. Vibration is present in most environments in one form or another. Whether it is from operating equipment, transportation, or even wind, it can cause problems with products, causing them to fail well short of how long they are intended to last. The first step is to see at what frequencies a design naturally vibrates for potential issues. With SOLIDWORKS simulation, it is easy to check natural frequencies, as in the case of this wheel rim. It is very important that natural frequencies do not occur near operating speeds to avoid potential resonance issues. When you design structures containing thin walls, static strength is not always the limiting design factor. Buckling can occur at loads well below material strength, so it is very important to ensure buckling is not going to limit the performance of your product. SOLIDWORKS simulation provides a very quick way of checking for linear buckling to address this. This makes it simple to evaluate different design options to ensure buckling is not an issue for the required load condition. Designs that incorporate motors, actuators, or reciprocating components that operate frequently can be subject to materials fatiguing over time. To avoid repairs after failure, it is incredibly valuable to identify potential fatigue issues and make changes to avoid or minimize problems. SOLIDWORKS simulation provides a quick fatigue check to let you know if loads are at a level where they may be a concern from a high cycle fatigue. You could then dive deeper into an actual fatigue analysis for a more accurate verification of the lifespan of the design to ensure it meets your performance goals. In many industries, a common way of checking robustness of a design is to perform a drop test. SOLIDWORKS simulation gives you the ability to drop a design from a specific height or with a certain speed and observe the response over the impact event. Not only does it help in understanding how stress propagates through the structure, it can monitor the acceleration on components, which is a key requirement in the electronics industry. For this electronic case, the effect of shock-absorbing end protectors can be evaluated for the acceleration on electronic components. Heat can adversely affect the performance of a design, whether it is from exceeding the permissible temperature of devices or by thermal expansion-contraction of components. SOLIDWORKS simulation allows you to evaluate steady-state thermal performance as well as heat analysis over time. So not only are you able to look at the current temperature, you are able to see how rapidly it cools down after a heat source is removed. For this brake rotor on a motorcycle, we can view the heat distribution from a braking operation and then look at how quickly the rotor cools afterwards. This can help in ensuring heat dissipation meets performance needs to prevent brake fade. You are even able to determine the structural effects from thermal expansion to ensure it does not cause problems. This has been a quick overview of the many powerful capabilities available in the SOLIDWORKS simulation products that can assist you in many disciplines and testing needs. All this capability is in the design environment already used, making updates automatic and reducing the time and steps to test your products. To find out more about these solutions, take a look at SOLIDWORKS Resource Center on this website or contact your local SOLIDWORKS reseller.